Okay, in this video we're going to talk about iterative equations. So once again, this is quite obscure, but each question we do, you'll notice a similar trend. In these questions, you're given a general formula. The general formula I've been given is un is equal to 2 times 3 to the power of n minus 5 times 2 to the power of n. This n is a little subscript n. It's just u and then an n, and it's a subscript n. The first thing we're asked to do is to verify that u3 minus 5 times u2 plus 6 times u1 equals 0. In this context, u1 represents what you would get if you subbed in 1 into this function. It's kind of like when in functions you're asked for f of 1, where you sub in 1, you've been given f of x, and if you're looking for f of 1, you sub in 1. Here I've been given u of n, and I know that u of n is 2 times 3 to the power of n minus 5 times 2 to the power of n. So in order to answer the first part of this question, I need to find u of 1. I need to sub in 1 into this and see what that's equal to. U of 2 means you sub in n equals 2. U of 3 means you sub in n equals 3. Once we've done that, we're then going to find un plus 1 and un plus 2. Un plus 1 is what I get when I sub in n plus 1 instead of n. Un plus 2 is what I get when I sub in n plus 2 instead of n. And then the third part of the question asks me to investigate if un plus 2 minus 5 times un plus 1 plus 6 times un equals 0. I'm jumping straight into an example in this video because you kind of need to see me going through one for it to make sense. But what I want you to do is to pause the video and take this down. I'm going to wipe it off and just look at part 1 first of all. So in example 1, we've been given the general formula u of n is 2 times 3 to the power of n minus 5 times 2 to the power of n. And the first part of the question has asked me to verify that u3 minus 5 times u2 plus 6 times u1 equals 0. So obviously before I can even worry about this, I first need to find u1, u2 and u3. So to get u1, I basically just rewrite this function, or this equation I've been given, except instead of an n, I sub in a 1. So I got 2 times 3 to the power 1 minus 5 times 2 to the power 1, so u1 worked out as minus 4. To get u2, I have to rewrite this, except instead of an n, I sub in a 2. So I get 2 times 3 squared minus 5 times 2 squared. 3 squared is 9 and 2 squared is 4. 2 by 9 is 18 and minus 5 by 4 is minus 20. So u2 works out as minus 2. Similarly, to get u3, I subbed in n equals 3. I got 2 times 3 cubed minus 5 times 2 cubed. 3 by 3 by 3 is 27 and 2 cubed is 8. 2 by 27 is 54 and minus 5 by 8 is 40. When I subtract the number 40 from 54, I get 14. So now I have u1, u2 and u3. I now literally just need to sub them in and hopefully everything cancels and I'm left with 0. So I've worked out u1, u2 and u3. And once I have them, the first part of this question is incredibly straightforward. u3 is 14, u2 is minus 2 and u1 is minus 4. So when I simply subbed into the equation I was given, I end up with 0 equals 0, so I'm happy out, and I've proven that part 1 is true. Okay, it's part 2 that we really need to focus on here. U of n is 2 times 3 to the power of n minus 5 times 2 to the power of n. We're then asked to find un plus 1 and un plus 2. So I've simply subbed in un plus 1 is this. However, I need to simplify this as much as possible or else I'm not going to be able to get part 3 correct. So let's talk about how we simplify this. In the next section, we're talking about powers and logs. So there's a little bit from the next section that you need to know for this, but to be honest, it's just revision of junior cert powers. On page 21 in the maths tables, on the top left-hand corner is the first rule of powers. And it tells me that if I have 3 to the power of n plus 1, that's the same as 3 to the power of n times 3 to the power of 1. If you look at the rule in your maths tables, it tells you that if you have a to the power of p plus q, it's the same as a to the power of p times a to the power of q. For the most part in the algebra, we're not worrying too much about rules of powers and surds. We'll look at that when we talk about logs. Now, if you have 3 to the power of an unknown, It is bad news. You cannot multiply this 2 by that 3. You cannot do it. You need to avoid it. However, what I can do is multiply the 2 by the 3 to the power of 1. 2 times 3 to the power of 1 is 6. So this term becomes 6 times 3 to the power of n. You cannot multiply the 6 by the 3. 3 to the power of an unknown is bad news. You should avoid it. You do not multiply it in. Let's follow the same logic with this. According to the first rule of powers on page 21 in my maths tables, 2 to the power of n plus 1 is the same as 2 to the power of n times 2 to the power of 1. I cannot touch the 2 to the power of n, but what I can do is multiply minus 5 by 2 to the power of 1. Minus 5 by 2 to the power of 1 is minus 10. So I just have minus 10 times 2 to the power of n. That is un plus 1 simplified fully. Let's have a look now at the next one. I also need to find un plus 2. To get un plus 2, I simply rewrite u of n, except everywhere there's an n, I sub in n plus 2. Once again, I can simplify 3 to the power of n plus 2 by using this rule from page 21 in my maths tables. If I leave the 2 where it is, 3 to the power of n plus 2 is the same as 3 to the power of n multiplied by 3 to the power of 2. And 2 to the power of n plus 2 is the same as 2 to the power of n multiplied by 2 to the power of 2. So I suppose I can simplify 3 squared and 2 squared. I can rewrite this as 2 times 3 to the power of n, and 3 squared is 9. And minus 5 times 2 to the power of n, while 2 squared gives me 4. And now I'm avoiding the 3 to the power of n's and the 2 to the power of n's. I don't want to go near them, but what I can do is multiply 2 by 9. 2 by 9 is 18, so this term becomes 18 times 3 to the power of n. And the second term I can multiply minus 5 by 4 and get minus 20 times 2 to the power of n. And that gives me my un plus 2. So now I have un plus 1 and I also have un plus 2. This is going to allow me now to answer part 3 of this question. In part 3 I was asked to investigate if un plus 2 minus 5 times un plus 1 plus 6 times un equals 0. I know that un plus 2 is 18 times 3 to the power of n minus 20 times 2 to the power of n, so I've subbed that in for un plus 2 at the start. I now have minus 5 multiplied by un plus 1, which I worked out in part 2 is 6 times 3 to the power of n minus 10 times 2 to the power of n. The last part of the equation is plus 6 times un, which is plus 6 times, I was actually given un in the original question. U of n is 2 times 3 to the power of n minus 5 times 2 to the power of n. I need to prove that this is equal to 0. The way that you need to treat this question is as if your 3 to the power of n's are x's and your 2 to the power of n's are y's. I have a load of terms with x's and a load of terms with y's in them. All of my x's should cancel each other out, all of my y's should cancel each other out. So essentially the 18 times 3 to the power of n, the 6 times 3 to the power of n and the 2 times 3 to the power of n are like terms that I can add or subtract from each other. Likewise, the 2 to the power of n, this one and this one are also like terms where I can add and subtract. I'm never going to multiply the 3 without, if it's a 3 to the power of n or a 2 to the power of n, I cannot multiply anything. I just have to leave it as it is. Obviously, for the first 2 terms here, there's nothing I can do. However, I have a minus 5 in front of this bracket. I can multiply the minus 5 by the 6 and then the minus 5 by the 10. Minus 5 times 6 times 3 to the power of n. Minus 5 by 6 is minus 30 times 3 to the power of n. Minus 5 times minus 10 gives me plus 50, and then I've that multiplied by 2 to the power of n. I have 6 times 2 times 3 to the power of n. All I can do is multiply the 6 by the 2, and that gives me 12 times 3 to the power of n. And then I have 6 times minus 5 times 2 to the power of n. I can multiply the 6 by the minus 5 and get minus 30 times 2 to the power of n. At least now I've multiplied it out. Now what I want to do is group my like terms. I have a term with a 3 to the power of n, a second one and a third one. So if we group those together, let's just see what happens. I have 18 times 3 to the power of n. I also have a plus 12 times 3 to the power of n, and I have a minus 30 times 3 to the power of n. I now have three terms that have a 2 to the power of n in it. I have this term, I have this term, and I have this term. The first one is a minus 20 times 2 to the power of n. The second one is a plus 50 times 2 to the power of n. While the third one, the third term with a 2 to the power of n, is a minus 30 times 2 to the power of n equals 0. We can just add these together now. 18 plus 12 is 30 times 3 to the power of n, and then I have minus 30 times 3 to the power of n. Clearly those are going to cancel each other out. Here I have minus 20 minus 30. So if I add the first one and the last one, I get minus 50 times 2 to the power of n, and then the middle term was plus 50 times 2 to the power of n. Clearly they're all going to cancel each other out as well. Plus 30 minus 30 is 0, plus 50 minus 50 is 0. So I'm left with 0 equals 0, so that means that it's true. So that's in general, that's the kind of question we get for iterative equations. If you're struggling with it, it might be worth your while to look at the first video we do in the powers and logs section, where we revise a lot of the rules for powers. However, you should be okay with it because it's all just junior cert powers. The moral of the story here is, if you have a number to the power of an unknown, you cannot touch it. You do not multiply the 3 by anything, or you do not multiply the 2 by anything. The very first line had a 3 to the power of n and a 2 to the power of n. I never once manipulated them, and my very last line still had the same 3 to the power of n and the 2 to the power of n. The only thing I can manipulate are the numbers before it. There's a second, completely different type of a way in which iterative equations can come up. In this question, I'm telling you that u of n plus 2 is equal to u of n plus 1 minus 3 times u of n. I'm telling you that u of 1 is minus 2 and u of 2 is minus 4. And you need to use this information to find u of 6. I want you to think of this as, this is term number 1 is minus 2, the second term in the pattern is minus 4. I need to continue it on and find the sixth term. If I know the first term and I know the second term, I can find the third term. Once I know the third one, I'll be able to find the fourth one. Once I have that one, I'll find the fifth one. And once I have that one, I'll be able to get the sixth one. So I need to repeatedly find the next term in this question. It's really important that you can identify the relationship between u of n plus 2, u of n plus 1, and u of n. If this is a specific term, u of n plus 2, then the term before it would be u of n plus 1. And the term before it would be u of n. So these are 3 consecutive terms in the pattern. I know 2 of the terms, which means I can find the next one. I know u1 and I know u2, which means the next thing that I need to find is what is u3. So I'm going to use the formula I've been given, or the equation I've been given, to find u3. I would always tell my students now to ask yourself, what does n need to be here in order for the left-hand side to give me u3? If I want this to be a 3, then obviously n in this scenario needs to be a 1. That's my starting point. That tells me that I need to start off by simply subbing in n equals 1. Let's investigate what happens if I sub in n equals 1. This will become u1 plus 2 is equal to u1 plus 1 minus 3 times u1. Let's just add these together so we have a bit more clarity. That means that u of 3, the third term in this pattern, is equal to u of 2, the second term in this pattern, minus 3 times u of 1, the first term in this pattern. So when I've subbed in n equals 1, I simply now have this. And since I know the second term in the pattern and the first term in the pattern, I'll be able to get u of 3. Because the question has told me that u of 2 is minus 4. So I can simply sub in minus 4. And that u of 1 is minus 2. So I can simply sub in minus 2. Now, minus 3 multiplied by minus 2 is 6. 6 minus 4 gives me 2. So if I simplify these numbers, it just tells me that u of 3 is equal to 2. Now that I have u of 3, I'm going to do something very, very similar to find u of 4. Let's just think about it here. I have u of 1 is equal to minus 2, u of 2 is equal to minus 4, and now u of 3 is equal to 2. I'm going to use this information to get u of 4. In order to get u of 3, I subbed in n equals 1. In order to get u of 4, I need to sub in n equals 2. So what I'm going to do is wipe off what I've done so far, and I essentially need to do it all again. If I wipe this off, I'm now going to sub in n equals 2. So instead of an n, I'm just going to put in a 2. This is going to become u of 2 plus 2 is equal to u of 2 plus 1 minus 3 times u of 2. If I simply add my little subscript numbers here, I get u of 4 is equal to u of 3 minus 3 times u of 2. In other words, the fourth term is equal to the third term minus 3 times the second term. And I'm happy enough with this because I know the third and the second terms. So in this case, I can deduce that u of 4 is obviously my u of 3, which is 2, minus 3 times u of 2, which is minus 4. Minus 3 by minus 4 gives me 12, and 12 plus 2 gives me 14. So that tells me that u of 4 is equal to 14. And now that I have u of 4, I need to keep going because obviously I'm trying to get to u of 6. So now I'm going to try and find u of 5. I subbed in n equals 1 to get u of 3. I subbed in n equals 2 to get u of 4. So now I'm going to sub in n equals 3 to get u of 5. So once again, I'm going to wipe this off so that it's clear and I can do it nice and big. If I sub in n equals 3 into the original function, I'm going to get u of 3 plus 2 is equal to u of 3 plus 1 minus 3 times u of 3. So now if I add my subscripts, I get u of 5 is equal to u of 4 minus 3 times u of 3. I'm happy enough with this because I know u4 and I know u3. So I'm going to be able to find u5. Instead of u of 4, I can sub in a 14, and instead of u of 3, I can sub in a 2. So I get minus 3 times 2. Minus 3 by 2 is minus 6. 14 minus 6 simply gives me 8. So u of 5 is obviously 8. So in this case, I know the fifth term here is 8. In order to find u6, I can use u5 and u4. If I'm trying to find u6, this time I'm going to sub in n equals 4. So let's have a look at our original. un plus 2 will become u4 plus 2. un plus 1 will be u4 plus 1, and minus 3un will be minus 3u4. If I add my subscripts here, I'll work out that u6, the sixth term, is equal to u5 minus 3 times u4. And luckily for us, we know u5 and we know u4, so the only unknown here is u6. So u6 will be u5, which is 8, minus 3 times u4, which is 14. Minus 3 times 14 is minus 42, and 8 minus 42 gives me minus 34. So I end up with u6 is equal to minus 34. And that would be my final answer for this question. The question asked me to find u6, so you work your way through the question until eventually you find the one that you're looking for. Okay, so I'm going to give you 3 questions that I want you to try here. The first 2 questions are related to the first example, while the third question is related to the second example. In the first one, you're told that un is 600 times 2 to the power of n minus 7 times 5 to the power of n. You're asked to verify that un plus 2 minus 7 times un plus 1 plus 10 times un is equal to 0. Before you look at the equation, the first thing you need to do is find un plus 1 and simplify it fully. Then get un plus 2 simplified fully. When you've got them simplified fully, only then will you sub into your equation and hopefully everything will cancel out. In the second question, you're told that un is equal to n minus 20 times 2 to the power of n. It's a similar thing this time. You need to prove that un plus 2 minus 4 times un plus 1 plus 4 times un equals 0. First things you need to do are get un plus 1 and un plus 2 and simplify them fully and then sub into the equation. The question 3 here is completely different. You're told that un plus 2 is equal to 2 times un divided by un plus 1. And you're told u1 is 8 and that u2 is minus 4. And you're asked to find u5. If you know u1 and u2, you'll first use the equation to get u3. And then you'll get u4, and then finally you'll get u5. So I want you to pause the video now, and I want you to attempt these 3 questions yourself, and then compare them to my solution. In the first question here, we had un equals 600 times 2 to the power of n minus 7 times 5 to the power of n. And we were asked to verify that un plus 2 minus 7 times un plus 1 plus 10 times un equals 0. In order to do this, before I even go near this equation, I need to have un plus 1 simplified fully, and I need to have un plus 2 simplified fully. I already have un simplified fully, so I don't need to worry about it. To get un plus 1, I just rewrote the original equation I was given, except everywhere there's an n, I put in n plus 1. And then I have a 2 to the power of n plus 1, which is the same as 2 to the power of n by 2 to the power of 1. Same logic here, 5 to the power of n plus 1 is 5 to the power of n by 5 to the power of 1. I want to avoid the terms with the unknown in the power, but I'm happy enough to multiply the 600 by the 2 and get 1200 times 2 to the power of n. And to multiply minus 7 by the 5 to the power of 1 and get minus 35 times 5 to the power of n. And that's un plus 1 simplified fully, which I'm going to sub in for un plus 1 up here when I get to that stage. Before I can do that, I also need un plus 2. It's basically the same logic. I just rewrote this, except instead of an n, I put in n plus 2. And 2 to the power of n plus 2 is 2 to the power of n by 2 to the power of 2. 2 to the power of 2 is 4, by 600 is 2400. So I get 2400 by 2 to the power of n. In the second term, my 5 to the power of n plus 2 is 5 to the power of n by 5 to the power of 2, and 5 squared is 25 by minus 7 is minus 175 by 5 to the power of n. And that's un plus 2 simplified fully. So now that I have un plus 1 and un plus 2, I'm going to sub them into this and hopefully everything's going to cancel. Okay, once you have un plus 1 and un plus 2, it's a relatively straightforward question. I've written out my un plus 1 and my un plus 2. And I was asked to prove that un plus 2, which is 2400 times 2 to the power of n minus 175 times 5 to the power of n, minus 7 times un plus 1, which I've subbed into this bracket, plus 10 times un equals 0. Remember that any number to the power of an unknown, you do not multiply it out. So what I can do is multiply minus 7 by the 1200, and in that case I got 8400 by 2 to the power of n. Minus 7 by minus 35, and I got plus 245, and that's by 5 to the power of n. 10 by 600 gives me 6000 times 2 to the power of n, and the 10 by this one gives me minus 70 times 5 to the power of n. You'll notice then that there are 3 terms with a 2 to the power of n in it. The first one is 2400 2 to the power of n, then here I've minus 8400 2 to the power of n, plus 6000 times 2 to the power of n. Ultimately, 2400 plus 6000 minus 8400 is 0. So these 3 terms cancel each other out. I then have 3 terms that have a 5 to the power of n in it. I have minus 175 times 5 to the power of n plus 245 minus 70. 245 minus 175 minus 70 is also 0, so they cancel out as well. So everything cancels out and I'm left with 0 equals 0. The tricky bit, I think, is to just fully and to simplify fully the first part where you get un plus 1 and un plus 2. In the second question, we were told that un is equal to n minus 20 times 2 to the power of n. And we're asked to verify that un plus 2 minus 4 times un plus 1 plus 4 times un is equal to 0. Before we do this equation, just like in question 1, the first thing we need to do is find un plus 1 and simplify it fully. Then find un plus 2 and simplify it fully. Once we have them simplified fully, we will then look at our equation. So what I've done here is I've worked out un plus 1 and I've worked out un plus 2. I've been told that un is n minus 20 times 2 to the power of n. So instead of n here, I subbed in n plus 1 and my power became n plus 1. So inside the bracket, I have n plus 1 minus 20. Obviously the 1 in the 1 minus 20 is actually minus 19. So inside the bracket I have n minus 19. Outside the bracket, 2 to the power of n plus 1 is the same as 2 to the power of n times 2 to the power of 1. And at this stage I can multiply the 2 to the power of 1 by the bracket. 2 by n gives me 2n, and 2 by minus 19 gives me minus 38. So un plus 1 simplified fully is 2n minus 38 multiplied by 2 to the power of n. Now I want to get un plus 2, so I'm rewriting the original un, except everywhere there's an n, I sub in n plus 2. Inside the bracket, I have n plus 2 minus 20, which is n minus 19. and 2 to the power of n plus 2 is 2 to the power of n by 2 to the power 2. 2 to the power 2 is 4, so it's actually, I can multiply the 4 by the bracket, but leave the 2 to the power of the unknown as it is, just don't touch it. 4 by n is 4n, and 4 by minus 18 is minus 72. So I can now say that un plus 2 is equal to 4n minus 72 multiplied by 2 to the power of n. So now I have un plus 1 and I have un plus 2, so I'm equipped now to answer the question that was actually asked. So I know un plus 1 and un plus 2. And I've been asked to prove that un plus 2 minus 4 times un plus 1 plus 4 times un is equal to 0. So here I've simply subbed in, this is my un plus 2, and then it's minus 4 times un plus 1 plus 4 times un. What I've done in the next line is I notice that I can multiply the minus 4 here by the bracket. Minus 4 by 2n gives me minus 8n. And minus 4 by minus 38 gives me plus 152. So you multiply the 4 by the bracket, but you ignore the 2 to the power of n and leave it outside. So I have minus 8n plus 152 times 2 to the power of n. You'll notice there's something funny about the signs here. I had to multiply minus 4 by this and then minus 4 by that. So the sign that I can put in front of that bracket is a plus, because if I put a plus in there it won't change my signs. Minus 4 by 2n is minus 8n, minus 4 by this gives me 152. So when I've multiplied that out, it's simply times 2n. Follow the same logic with the next one. 4 by n is 4n, 4 by minus 20 is minus 80. So it's that times 2 to the power of n. At this stage now, I've decided to multiply the 2 to the power of n into each bracket. Remember that you can't really do anything with the 2 to the power of n. 4n times 2 to the power of n, I literally just write it as 4n times 2 to the power of n. And then minus 72 times 2 to the power of n. And then it was 2 to the power of n by each of these terms. You're basically just rewriting the terms with a 2 to the power of n after them. 4n by 2 to the power of n is the same thing. Minus 80 by 2 to the power of n is the same thing. And then what I realised is that I have a number of like terms. Every single one of my terms has a 2 to the power of n. But 3 of them have 4n, or a constant, and then n times 2 to the power of n. 4n times 2 to the power of n minus 8n times 2 to the power of n plus 4n times 2 to the power of n. These are like terms. 4n and 4n is 8n, so they would add up. 4n plus 4n is 8n, minus 8n is obviously 0. So these 3 terms cancel each other out. The other 3 terms were also like terms, so I've grouped them together. I have 152 times the unknown minus 72 times the unknown minus 80 times the unknown. Minus 72 minus 80 adds up to minus 152. So obviously 152 minus 152, that also cancels and I'm left with 0. So I'm happy enough with this, and I can say that that one was true. In question 3, we were told that un plus 2 is equal to 2 times un over un plus 1. And we were told that u1 is 8 and u2 is minus 4. We were asked to find u5. Before I can find u5, I first need to find u3, and then u4, and eventually u5. So this question is similar to example 2 at the start of this video. If I know u1 and 2, the next thing I need to get is u3. So I have to ask myself, what should n be if the left-hand side needs to be u3? In order for the left-hand side to be u3, then n would have to be equal to 1. Let's just investigate what happens to this if I sub in n equals 1. I'm going to get u times u1 plus 2, that'll be u of 3, is equal to 2 u1 divided by u1 plus 1. And if we simply add our subscripts here, I get u3 is equal to 2 times u1 over u2. The third term is equal to 2 times the first one divided by the second one. Luckily for us, in the question we were told the first term and the second term. So I can simply sub in. That must mean that u3 is 2 times 8 divided by minus 4. And if you plug this into your calculator, 2 times 8 is 16 divided by minus 4. That tells me that u3 is in fact minus 4. So now that I know u3, I'm going to be able to find u4. And once I get u4, I'll be able to get u5. In order to get u4, I need to use a different value for n. If I've used n equals 1, obviously the next one I need to use is n equals 2. So now I'm going to wipe this off and do a similar thing again, except for subbing in n equals 2. Okay, so when I sub in n equals 2 into this equation, I get u of 2 plus 2 is equal to 2 times u of 2 over u of 2 plus 1. Or in other words, u of 4 is equal to 2 times u of 2 over u of 3. Luckily, I know what u of 3 is and I know what u of 2 is. Both of them are actually minus 4. So I end up with u of 4 is 2 times minus 4 over minus 4, which in this case u of 4 works out as 2. Now that I know u of 4, I'm finally ready to try and find u of 5. I'll find u of 5 if I sub in n equals 3. So when I subbed in n equals 3, I ended up with u5 is equal to 2 times u3 over u4. I've worked out previously that u3 is minus 4, so the top becomes 2 times minus 4. And I worked out in the last one that u of 4 is actually 2. So the 2 divides into the 2 once, and I'm left with u of 5 is equal to minus 4. So my final answer there is just u of 5 is equal to minus 4. So that's all we're looking at in terms of iterative equations. There's loads of different ways in which they could come up. The way that I think that this type of question is the most likely type of question you'll get on an iterative equation.